Hey everyone, so today in this video I just kind of want to show you a little bit into C++ pointers. I want you to get a better understanding of it, because when we first see it we might see something like this, where we have int x equal to 7, we just have some variable, and if we want to have some pointer to this variable, we'll have int star, some variable name XPTR for x pointer is equal to ampersand x. And this on its own, yeah, it works, but it's hard to visualize. It's not the best for understanding's sake. And so hopefully with this short video, you can get a better understanding of what's going on here and a little bit in visualizing how pointers are working. So with that, let's get into it. So first off, when specifying a variable, you may think of it as just a container, right? And so it's just we have some container named x, and inside of here we're just storing the value of 7, right? Simple as that. But this on its own, it's not very helpful. So what's another way we can visualize this? And so we can actually visualize this as x being our memory cell, because of course we're reserving some memory inside of our program to hold the value of 7. And so the only difference between the left image and this image is that we're going to take into account the data type of this memory cell, and in this instance the data type would be here, this would be an integer. And we're also going to note down the memory address. Basically the address, or the address for where this cell is stored within memory. And so along with this, we're going to have, of course, our variable name as we're used to, and also our variable value. And so these 4 components make up our memory cell. And so just so it's a little bit more clear, an example for int x is equal to 7 up above, we can do it step by step. We might first say int x, where this is our declaration. And what that's going to do for us is it's going to first specify, okay, let's reserve some memory here for x, in which I'm going to only be able to store integers, right? That's what this first part is saying. And of course, memory is going to be reserved. There's going to be a specific address where this data is held. And in our case, let's just say some hexadecimal value, 0xAF20. It's really any random value. So it's dependent on how the programs run. But yeah, so this is how your memory cell would look like as of right now. And say on the second step, we want to say int x is equal to 7, in which that would be our initialization. So let me just move this over here. This right here is your initialization. Feel free to roast me if I misspelled that. But yeah, and so what that would do is it would allow us to store our variable value into here. And so now this on its own is our complete memory cell. But how exactly does this relate to pointers? How does this help us? And before jumping into that, it's important to recall 2 operations that you can use with pointers. And so let me actually just erase this. And so for our operators, 2 important operators for us. First off is going to be the ampersand, and then parentheses, just noting some variable in here. If you just want to note down some variable. And what this is this is our reference operator, specifically just the ampersand. And the second operator is the star, in which then we would include something to the right of it, some variable. And this is our dereference operator. And again, important note that the dereference operator is specifically just the star, but the parentheses and the variable here just to indicate how this would be used or indicated when using it. And so, with that, let's bring back our memory cell. We'll use the example we used before, where we have our int, we have x. We'll say, recall that our statement is int x equal to 7. I forgot what the memory address we specified is. I think it's AF20. Might not be, but again, that doesn't matter. And our value is 7. And so let me just fit in everything onto one screen. And so with our reference operator, doing a statement such as, let's see, ampersand x. If you recall, if you've seen this operator used before, getting the reference of x is the same thing as getting the memory address. And in terms of our memory cell here, this would be our 0xAF20 memory address, this hexadecimal value indicating our memory address. And so what we can actually do is we can draw some arrow. Let me actually just color code this. Going from x to our memory address, indicate the symbol, the ampersand symbol, denoting that if we use this ampersand symbol starting from our variable value, we can get the memory address over here. Now, what about the dereference operator? Now, as the name implies, it kind of almost feels like it's an opposite of the reference, right? Because if you reference something, you can dereference it. And so what's actually going on with the dereference operator is you may see it used in something like a pointer. So if I have something like int XPTR, this is a type pointer, is equal to ampersand x, then what's actually going on here is I'm saying, okay, I have an integer pointer and I'm calling it XPTR. This is equal to the memory address of x. Perfect, right? And so XPTR on its own, what is it storing? It's storing 0xAF20, that specific memory address. Now what I can do with the dereference operator is I can put the star, dereference, indicate our pointer variable, XPTR. And what this is actually going to give me is 7. And so I'm dereferencing that previous reference that I made. And so, like how the name implies, they are opposites, or not entirely opposites. You'll see what I mean. But what we can do is we know at XPTR we are at our memory address location here. And so if we use the dereference operator, then we'll be able to move down over to our value, and I'll indicate a star to indicate that the dereference value will allow you to move from the memory address over to the value. And so say if we do want to go from x and outputting 7 in some other way than just printing it, Of course, printing just X, that also gives us 7, in which we can indicate that by an arrow, going just from X directly to 7, just like that. We don't need to indicate everything. So what you can actually do, let me just scoot this down, is if you still wanted to output 7, you can have X, that's your starting point, of course. We're going to use the reference operator on X, so that moves us from X over to the memory address. And then what we're going to do is we're going to dereference that, which is then going from X over to our memory address, which is the first portion here. And then from the memory address, we're going down to our variable value, which is by the dereference operator here. And so this will also give us 7. So this is just a way to use the operators to kind of move around the memory cell. That's really what these operators are doing. These operators up here, let me just get a different color here. Number 1, number 2. These operators are just, you can think of them, they aren't exactly, but you can think of them as ways to move around the memory cell, which is kind of cool, right? It gives you some way to visually see what's going on with these operators. But that's fine and dandy, but where do pointers come in with all this? So with pointers, something interesting happens. Let's say, let me see if I can zoom out here. Perfect. So let's say, for instance, this section over here. What I was doing over here is I was declaring and then initializing a pointer. So let me just rewrite this. So we're going to have int star in an integer pointer. We're going to call it XPTR. Let's do it line by line. So this is first going to be our declaration. And so what's that going to do? I'm going to create a memory cell. And the memory cell is going to be of data type int pointer, int star. And then, of course, this is just pointers are nothing, they're special and they're really useful, but in terms of just their memory cell, they're nothing too special in terms of they still have a variable name. They have a memory address just like everything else. In this case, the variable name is XPTR. It can be anything you want. The memory address will indicate if this integer is 4 bytes, then the memory cell should be right next to it, which would be 4 bytes ahead. So we'll just say AF24. But again, this doesn't matter. This can be anything. It can be further down in the memory. But yeah, it doesn't have to be right next to it in memory. It doesn't have to be right next to this memory cell. And so, but moving on from that, the next thing we're going to do is we're going to initialize our pointer by saying XPTR is equal to &x. Ampersand is our memory address of X. This is our initialization. Hope I'm spelling that right. Running out of room here too. Initialization. There we go. And so you might say, okay, well, this value right here is just &x, right? Nothing special. Not entirely though. So yes, this is &x, but recall that we're not storing just any old integer, right? Because &x on its own, this would be just the memory. This would be just like the memory address of X. And so yeah, I can just say it's 0xAF20. But the reason why pointers are so special is because here we're not indicating that we're storing some integer value, some hexadecimal value that just has some memory address. What's actually going on here is by storing the memory address, we're creating some pointer, if you will, that is essentially making a path directly over to this memory address over here. And this is why you can think of them as pointers, because they are pointing to this memory cell. It allows us to directly access this memory cell through this pointer here. And so, like I said, this pointer memory cell is nothing special. If we start out from our variable here, we can move on from our variable over to our memory address by using the ampersand. And from our memory address, we can move over to our value by dereferencing our memory address. And if we just jot down the variable name, we'll just move directly to the value. That is to say, if you want to see it written down, just slide this over. If I have down just, let's say, ampersand XPTR, that's just going to be 0xAF24, the memory address of our pointer. And if you just jot down XPTR on its own, this will be 0xAF20. This is the memory address of X. And if you want to be quirky and just take a different path to the same value, you can say ampersand XPTR and dereference that. And this will give you the same value as XPTR here, the memory address of X. But let's think about it. What's actually going on here? So when I am getting the memory address here, again, I'm not just getting a value, because if I just got a value on its own, there's really nothing special about this. What I really want to do is also navigate through this memory cell, in which pointers allow me to do. Because again, this pointer here that I can follow, it's a path. It's not like this path doesn't exist and I'm just storing the value 0xAF20. It's nothing like that. So what I can actually do here is, let's say, let me slide this over, get more room, still have both memory cells on the screen. And let me actually just erase this. I'll keep that there. So if I had something like XPTR, let's first follow this step by step. At XPTR, I'm starting right over here on the pointer memory cell, moving down into this value here. But what is this value? Well, this value takes me down this path into this memory cell right here. And so if I'm right here on this, on the integer memory cell, then if I want to get 7 down here, what do I need to do? Well, according to our graphic here, we just need to dereference this value. That's all we need to do. So I'm going to dereference this pointer, and what value is this going to give me? 7. And this is why sometimes you might see something like int star XPTR is equal to %x. And if you wanted to get the value of x from the pointer, you would have to dereference the pointer. Seeing this on its own is just confusing. Like what do you mean dereference this pointer? Like what's going on? This is what's going on the side over here. Because from XPTR, you're going into the memory address for x, and then you just need to do a simple dereference to get the value. And so let me actually back this up. There we go. And let me just jot that back down just so the graphic looks a little bit cleaner over there. So we said, oops. And so we said that XPTR, starting here, moving to the memory address, and dereferencing that, this will give us 7. And so it's important to note, similarly to how we are not just storing a value in, like, that's the same as the memory address. We are not just, if we have this 7 here, we're not just getting some random value 7. We're specifically accessing the value 7 that is stored inside of this memory cell for x. And so this is why, if you had something like star XPTR, if we dereference XPTR, which gives us the 7 over here, is equal to, let's say, 8 now. Instead of this just changing any old random value, what it's actually doing is it's changing the value inside of our X memory cell. And so I can actually erase this now and put down 8. And so if I just print X on its own, starting from X, moving down, this will, I'll put 8. So by directly changing the value from the pointer, we've managed to change the value of x. It's a little bit weird, but it's really cool. And so with this, you can get, once you kind of start to understand the pattern, or just like the graphic for how you're navigating around this memory cell, you can kind of start to do a little bit complex or just funky things with pointers. And so let me actually just start to rewrite stuff over here. Let me actually just clear out the screen. And so let me jot down the pointers that we had. So let's see, we'll say int x is equal to 7. Int star XPTR. Actually, just so you guys aren't confused about the name has to be the variable name followed by XPTR, we'll just call this y. It's still an integer pointer. It's going to be equal to the memory address of x. And so let's note down, this is our first, let's just say this is a memory cell for our pointer, pointing to an integer, y, 0x, af, 24, and this is going to be pointing to memory address type int, which this is x, 0x, a, f20, and the value for this is 7. There we go, a little bit cleaner. So now let's say if, I don't know, we wanted to have a pointer that points to y. So what we can do then let me slide this over, is we can then say something like int, actually, let's go one by one here. So what we're going to need to do is from int on its own, we have int star, because this int on its own here is just an integer. And then int star is specifying an integer pointer. Having this star here is indicating that you have a pointer to a type int. So what if we wanted to do something where we maybe have some pointer that points to this pointer? Well, in that case, we would need to have an integer pointer. It's kind of weird when you hear it said out loud, but let me see if I can make this clear. So you have an integer pointer, parenthesis, pointer. It's a pointer that points to an integer pointer. So it's a little bit weird, but should still all work out the same. Int star here. And so what we're gonna do is, let's see, getting a little bit messy here. Let me see if I can slide down. There we go, a little bit better. So what we're gonna do is we're gonna declare a third variable, int star, let's just call this z, is equal to, before we get into that, let's first just jot down our values. So this is a memory cell of an integer pointer. And then what we're gonna do is we're gonna jot down the name, z, the memory address. Let's just call this 0x, I'm getting lazy, so I'm just gonna put FFF, fourth F, yeah. Yeah, and so what's this value gonna be? So if we wanna have it, say, point over here to our integer pointer, then the value of z is gonna be the memory address of y. Because recall from before, all these memory cells, you can navigate them from our operators. All these memory cells are the same. Same goes for the pointer to an integer pointer. And here. And so let's say from this double pointer or integer pointer, we then wanted to get the value of 7. Now how would we do that? Well, of course, first our starting point is z. And z, where is that going to take us? Starting from z, moving down here, traversing along our reference to this memory address. And so the first thing we would want to do now is use the dereference operator to get the value of this memory cell here. And then where's that going to take us? To this value, which this value allows us to follow through this pointer into this memory address here. And now the final step, we just need to have one more dereference to get 7 down here. And so we're actually going to have a second dereference here. And what this will actually give you is 7. And we can do the same exact thing as before. If we wanted to change the value, we can say dereference of z is equal to 8. And what that will do is it will change this 7 into an 8, and that will affect it for this pointer and as well as the original variable of x. Of course for itself too, the double pointer as well. And so yeah, now you may be wondering kind of why did I show you this double pointer stuff? Well, one, it's just interesting. It might allow you to kind of form a better thought about pointers in case if maybe you might have had some wrong assumptions from just seeing the example where you just have a single pointer. And two, just to maybe allow all of you to make a connection and see how, if you're familiar with this term of linked lists, how it kind of looks like we're forming that, where we have kind of one object pointing to another, in which we can just kind of keep on going and have a list going on of these pointers. And so what's actually going on is how we can make the connection here is that instead of just using, say, just a random old pointer in which you can just only store the memory address in here, what you'd actually do is you'd have a class. You make a class such that you're mimicking this pointer, in which you would have some name. Of course, you'd have a memory address, but in terms of linked lists, we wouldn't need to really worry about it too much, because what's actually going to happen is now inside of our data here, our variable value. Now we're going to get rid of this, and since this is a class now, we'd be able to have something like a pointer here and maybe some data here, and this pointer can then point to another memory cell or container of data in which it has its own content. It has some data and it has its own pointer as well. And yeah, this will just keep on going. If you really want to make a linked list from that, in which these instead of calling these memory cells, we would call these nodes, or not each of them is a node. Together these are nodes, and altogether this would essentially be a class node that has all this data for you, and then your class linked list will then use the class node in order to make a list. Make a list of nodes, plus some functions, so that you can interact with the interface of the linked list. But yeah, that whole last part, don't need to worry about it too much. If that was really weird, at least hopefully the beginning content on the actual pointers helped out a lot, because that's the way how I visualize everything. But yeah, so hope that helped out, and see ya.